Okay, this will be the last video of chapter 10 section 2, and this should appear in your exam as well. And this is the permutation rule when objects are alike or identical or non-distinct. Now, the number of permutations for n objects in which k1 objects are alike, k2 objects are alike, and etc. is this formula: n factorial divided by k1 factorial times k2 factorial times k3 factorial times so on, so on, and so on. And these are a permutation for when objects are alike. They're non-distinct. So I'm going to do this example here, and you can determine when to use this formula, because when I want you to arrange objects that are non-distinct, it will mention that the objects are non-distinct or the objects are identical. For this one, it says how many passwords can be used. How many passwords can be made using all the letters of the word Mississippi? And if you notice, ignoring the capital M, the letters I's, S, and P's are the same. There's really no difference. The I in the middle does not change the I at the end. Although they're in different locations, the I is still the I. So we want to find out how many ways we can order that, right? Step number 1 is determine how many objects you have in total. How many letters are in the word Mississippi? In the word Mississippi, there are 11 letters. Now, let's let K1 be the number of M's. There are only one M, so that's going to be 1. Let K2 be the numbers of I's in Mississippi. If you count, there are 4 I's. Let K3 equal the number of S's in Mississippi. There are 4 S's in the word Mississippi. Let K4 be the number of P's in Mississippi. That's going to be 2, which are at the end. Once you do that, we can plug it into the formula. And also, I put my factorial mark there. So that will be 11 factorial on top, divided by 1 factorial for the number of M's that we can arrange, times 4 factorial for the number of I's we can arrange, times another 4 factorial for the number of P's, times 2 factorial for the number of, 4 factorial for the number of S's, 2 factorial for the number of P's. And now what we can do is we can plug that all into our regular calculator. But I advise you to take your step by step. 11 factorial, what is that going to be? 39,916,800 divided by 1 factorial is just 1. 4 factorial is 24 times another 24 times 2 factorial, which is going to be 2. Next, we're going to multiply our denominator. So 39,916,800 divided by, if we multiply the bottom, that's going to be 1,152. Let's divide that by 1,152. That equals to 34,650 ways the password can be arranged. And a question like this, you may see when it comes to identical sweaters or canned foods on Alex. You know, it will say the word identical or non-distinct, and it'll ask you for the number of ways you can arrange those objects. If it says identical or non-distinct, use this formula. If it's not identical, and if it is a distinct object, and it wants you to find a number of ways in which the order matters, you will be using this permutation formula, or you can use the fundamental counting principle. So hopefully you guys can see the difference between those two. You can be able to differentiate between each. Alright guys, that is it. And I'll see you guys soon. Adios.